In this lecture, we are going to learn about image contours. Image contour is nothing but a technique where you can identify the boundaries around the various objects in the image, and thereby you can extract the individual objects from the whole image. So let's see this visually. Consider an image where you have a hollow rectangle and a circle, and let's say if you want to draw the boundaries around this edge of this each of the shape, then the way that can be done is identifying the contours and then drawing the contours in the image. So when you apply contouring, this is what we get. So here you can see, as far as circle is concerned, it's identifying the boundary and just drawing the circle around it. And in case of rectangle, there are two rectangles, one embedded within another. It's identifying both the boundaries, the boundary of the external and the boundary of the internal rectangle. So that is what I meant by finding and drawing the contours, right? So let's see this action by looking at some code. So if you ever want to look at the code, what you can do is, I have open source this code on GitHub. You can search for my ID, which is Evergreen LLC 2020, and there is just one repo right now. It's called CV, which stands for computer vision. You can download the whole repo by copying this URL and running git clone command and just specify this, or you can also download the zip and extract the zip. You will download the whole code base. The particular notebook that we are looking at is contours.ipynb. So this is the code we are looking at. So all the code and the image are inside this folder. So you can just download and just open the folder and start practicing. So this is the contours.ipynb file. I'm going to zoom in a little bit so that you can see it better. Let's go through the code. So I'm just initializing, importing few packages at the beginning, which are known packages like OpenCV2, which has the functions for finding the contours. Then the NumPy library, which is used for manipulating the images mathematically. Then I'm also importing a matplotlib library to help with drawing those images on the screen. And then I'm also exporting imutils, which has several utility functions for images. So in order to execute this cell, you can just hit Shift Enter. That cell gets executed. And if there are any errors, you will know. One of the errors that you might face is import imutils. If you haven't installed, you face the error that unable to find this package. When you get this error, what you do is go back to your Anaconda command prompt, right? Then right click on this, open terminal, and you can just run command pip install imutils, and this will install the package for you. I'm not going to do that because I have already installed the package with me. So once you install that, you can come back here and then just restart your kernel, okay? And then that error should go away. And just run this cell again by Shift Enter, and this error should go away. Next, I have two utility functions, one for displaying the color image and the other one for displaying grayscale image. I use this function a lot throughout this code, so that every step of the code I can display what changes has happened in the image. And I need two functions, one to display color image and one to display the grayscale image. So let's look at the display color image. This function takes an image, which is a NumPy array, and the title of the image that we want to display. So inside this code, it just calls the matplotlib's imshow function, and it first converts the BGR format to RGB format, because our original image is in OpenCV format, which uses the BGR format, but matplotlib uses RGB format. So we first need to convert from BGR to RGB, and then just use the nearest interpolation to get the best quality. and you can just set the title, and then you can show the image, right? Similarly, for display grayscale image, it takes image numpy as input, title as another input, and it calls the matplotlib imshow function, passes in the image, and it passes the gray CMAP because we want to display only single channel grayscale image, and we also specify the minimum and the maximum value of the image intensity. Then we again set the title and we show the image. So this, since we are going to call this we are going to display the images over and over again, it's better to use these subroutines or methods rather than calling these 3 lines and these 3 lines everywhere that we need. So I'm going to execute this line by pressing shift enter, shift enter. So these 2 lines are executed. So the functions are so your notebook is aware of this function. So first thing, I'm going to draw a very simple image. I'm going to initialize by a black image with 600 by 600 size, 600 width and 600 height, and this is 3 channels, so it's a color image. Then I'm going to initialize a pen which is of green color, and then I'm drawing a rectangle on this surface, which is the from this point to this point with the green color pen and the width of 30. Then I'm also going to draw a circle on the same image, which has a radius at 400 by 400. Then this is the center coordinate, right? And this is the radius of the circle. This is the pen with which I'm going to draw the circle. This is blue color, and then the width of the circle, right? And then I'm going to display the image, which should show me the rectangle and the circle drawn on this image. So let's run the code. So as you can see, we see 2 images, one for circle and one for the rectangle, right? The next thing what we're going to do is, before we identify the contours, we want to convert this into a grayscale image. So which will remove the color information, and the way to do that is we simply call a cvt.cvt color function, pass in the surface and convert it to specify that we want to convert from BGR to RGB first, and then from BGR to grayscale image. So you get a grayscale image here. All the color information is removed because for drawing the borders we really don't need the color information. Now we come to the meat of this code, where we want to find the contours in the image. Basically we want to find these coordinates around the edges. So in this image we see at least 3 edges. One around the outer rectangle, right? One around the inner rectangle, and one around the circle. So these are the 3 contours or the edges that we want to find by using OpenCV code. So to find the contours, OpenCV2 has a simple function called find contours. And since this is a destructive function because it's going to modify the original image, and we don't want to modify the original image, so we make a copy of the image first and then pass it to the find contours function. And then we say the second parameter says get me the all contours, internal as well external. And the third parameter says use an approximation, so that rather than finding each point around the border, just find the vertical, horizontal and diagonal lines and their endpoints. That's good enough as far as the approximation is concerned, right? So this will return me a tuple of contours objects, and then I'm going to normalize the contours into a format that different versions of OpenCV understands, and that is where this imutils.grab contours function is really helpful, right? All we need to understand is it just converts to a format that a lot of different versions of OpenCV understands. Then we're going to display those contours, and then what we'll do is we will take the original image, we'll make a copy of that, we'll clone it and call it a CL, and then we will draw the contours on this cloned image by passing the clone image as input using the draw contours function. It requires the clone of the image as the input because we are going to modify that image, then the contours we want to draw, then -1 to include all the contours. This is the color that we are going to use to draw the contours. So this is red color, BGR, and this is the thickness of the contours, right? So you're going to just find the contours and print it. So So these are the contours it's printing, the coordinates of the contours. And now we're going to display the image, which will show me the contours around that image. So this is the red color with which it's identified the borders, the contours of the image. So it has found the three contours, one for the outer rectangle, one for the inner rectangle, and the third one is for the circle. So let's say if you're interested only in the outer boundaries and not the inner boundaries, so the only change you need to do is in the find contours function, instead of saying cvt.retr list, which we did here earlier, you just say cvt.retr._external, and the rest of the code is exactly same. So let's see what happens when you specify this. So what it will do is it will not identify the inner boundary, but it will identify all the external boundaries, right? So how do we use this information? So let's say so far so good, we have identified the contours or the boundaries. How do we use it? So this information is extremely useful for isolating the various objects in the image. So let's say if you want to isolate the circle and if you want to isolate this rectangle into a different image, how do we do that? So to do that, what we do is we run a loop for each contour in all contours. We first create a mask. So mask we create by creating a complete black image, which is of the same size of the grayscale image, right? Then on this black image, we are going to draw a contour, each contour starting with circle first, and then in the next iteration of the loop, we'll draw this another image, right? So take one example at a time. So in the first iteration, it takes circles boundary, and it just draws the boundary on that new black image, right? And this is the white color. It will fill with the white color. So what this function will do is, and we can see this in picture also, it will draw a white circle which is at the same position as this circle, right? And then we are going to use that, we'll display that image, we'll display the mask, and then we are going to use that image as a mask, and we'll do bitwise ANDing with this whole image. So what will end up happening is it will only retain the circle, but it will remove everything else. So this is what the bitwise AND does. Similarly, in the next iteration of the loop, it will identify this as the boundary. It will draw a mask with this boundary, which is a rectangular mask, and filled in with white color, and it's going to bitwise AND with the whole image. So it will remove everything else, but it will retain the rectangle. So let's see this in action. I'm going to hit shift enter. So it's executing. So let's say that in the first iteration, it's showing me the original image first. Then it's showing me the mask that it has drawn in the first image. So what it has done is it has identified the boundary of the circle and has created another circle which is filled in with the white color. Remember, the white color is value is 255, black color value is 0. So the next thing what we're going to do is we're going to add this bitwise AND this mask with the original image. So what will happen is wherever there is a black, its value is 0. So 0 ANDing with anything in the image will always be 0, right? So that means this rectangle will be removed. Whereas in the case of circle, we are ANDing with all 255. So it will anything ANDing with 255 will just take the same value. So the circle will be retained, but everything else will be removed. So when you add this image with this image, the result is this image. So this is how we have isolated circle by creating a mask and then doing a bitwise ANDing with original image. Similarly, again we display the original image for the second iteration in the loop, and that time we create a mask for this rectangle. So as you can see, it has drawn a white rectangle, and then we do bitwise ANDing with the original image. So what will happen is apart from the rectangle, everything else will remove because it's going to AND with zeros. That's the black color. And then when you add this with this, only the rectangle will remain, everything else will go away. And this is the image, right? So this is how the contour information is very, very useful for finding the boundaries of the objects in the image and then isolating them one by one.